video, we'll establish a strong and open source foundation for Kubernetes networking using Cert Manager and Nginx Ingress. This combination gives us a configurable and HTTPS encrypted way to expose our applications and has a low ongoing operational overhead. While this setup has great flexibility around how to run SSL certificate ACME challenges, we'll specifically use a Cloud DNS approach in this video. We'll also leverage Google Cloud for our Kubernetes environment. If you are using a different ACME challenge approach or Kubernetes environment, you should still be able to follow along with this video. The Nginx Ingress controller is going to be the foundation for how we create Ingress resources that publicly expose our workloads. There are actually two Nginx Ingress controller projects, one that's led by the Kubernetes team and one that's led by the F5 Nginx team. We'll be using the former option. The demonstration code is linked in the description of this video, along with links to the various open source projects. So let's clarify the full networking flow for how users will access our workloads on Kubernetes. First, they're going to go through an Ingress, which we'll provision with the Nginx Ingress controller. That Ingress is going to reference a Kubernetes secret, which holds our SSL certificate information. Those certificates will be provisioned and managed by Cert Manager. Behind the Ingress, we're going to have Kubernetes services, which provide a networking front end for our deployments. The deployments themselves are a logical organization of containers used for rolling out and managing applications. Ultimately, everything except Cloud DNS will be on Kubernetes, so we'll be heavily relying on Helm and kubectl commands. While this might seem complicated at first, we'll carefully walk through every step, provide you with reference code, and explain provisioning commands. Once you're familiar with the building blocks that we demonstrate during this video, you'll be able to adapt them to a wide variety of Kubernetes networking situations. With everything now laid out and our objective defined, let's go ahead and jump into the Google Cloud Console and an IDE environment to set this up. We're going to start with the Helm command for installation of these resources here. Then we'll look at kubectl installation of these resources. So I'm in a Google Cloud project now, and I'm using the Cloud Shell IDE, which can be accessed with this button here. Then just click Open Editor when that pops up. We have some YAML files from the aforementioned GitHub repository and this README that we can crack open to see setup steps. While we'll create these resources from the Google Cloud CLI, you could, of course, create these resources in the Cloud Console GUI. The first thing we need to do is set our project ID in the console, and I'll grab that from the homepage here. We'll set that as an environment variable. Next, we need to create our Kubernetes cluster and get the credentials for that cluster. There are a couple noteworthy and non-default configurations here. Specifically, we're going to use workload identity for a seamless bridge between Kubernetes RBAC and Google Cloud RBAC, which enables things like automated Cloud DNS updates via Cert Manager. The other non-default configuration is an explicit specification of broad API scopes access, so that our Kubernetes cluster can reach out to whatever Google Cloud services that we need programmatically. Even if you have the permissions from an IAM perspective, the API scopes can constrain service access, so we want to open that up beyond the default setup. We're going to name the cluster OSS Networking Sandbox and specify a zone. As alluded to earlier, you can use other managed Kubernetes providers or even a DIY cluster setup and still generally be able to follow along. If you're using a different Kubernetes environment, the big difference will be how you approach the ACME challenges for Cert Manager. The Cert Manager project has a wide range of integrations, so it's probably relatively easy, but you'll need to consult the documentation for your specific use case. Now, this is typically going to take about 5 to 7 minutes, and that's for a pretty default cluster configuration. Running the default configuration for a month would incur about 150 US dollars. So bring the node count or node sizes down if you need something cheaper for a long-term setup. As you can see from the console here, we are going up and running with our cluster. So let's go ahead and get the credentials for that cluster now. This will allow us to target the cluster with Helm and kubectl commands. The next few commands are going to create a service account, which is used for the integration between the Kubernetes cluster and Cloud DNS. Specifically, we create the service account, find a couple roles, set up the workload identity, and generate a key. If your Cloud DNS zone is in a different project, you'll need to adjust for that in the commands here. All right, let's go ahead and run the commands. To expedite the demo, I've already created most of these resources in advance, so your output will look a little different than mine. As we start to run kubectl and Helm commands, note that you'll of course need the respective CLIs installed. By using the Cloud Shell IDE, we have those CLIs ready to go out of the box. Let's first use Helm and add the Helm repo for Cert Manager. When you install Cert Manager, an important piece to remember is this custom resource definitions argument. When we install with that argument, we can create resources like certificates simply by applying them as Kubernetes YAML files. It's typically about 2 to 3 minutes until the Helm installation shows is completed. The last step here is to update the service account that was provisioned by Helm so that it's connected to the required workload identity permissions. We'll do that with this command here. Notice that this command uses the exact same service account as we provisioned earlier up here. With the installation now complete, we can configure Cert Manager, telling it how we want certificates to be provisioned. This cluster issuer resource is a custom resource definition that does precisely that. In this configuration, we're choosing Google Cloud DNS and a specific GCP project for DNS Acme challenges. As you follow along, if you're using Cloud DNS for your Acme challenges, you'll need to change this to your own project. Further down, we have a certificate resource. This resource will provision an automatically managed SSL certificate for this domain. We'll store that SSL certificate in a Kubernetes secret so that we can use it in Ingress definitions. Okay, so let's apply all those resources now with the kubectl apply command. We generated a JSON key file for our service account earlier in case you need to play with the authentication, but just be sure to keep that private. Don't commit or share that file. On to the ingresses. Let's get the Nginx Ingress controller installed. This will allow us to create highly configurable Ingress resources. We'll use a Helm-based installation, which is quite similar to the Cert Manager case. We'll first add the Helm repository, and then we'll install the Helm chart. So let's grab this installation command and install using the name Ingress Nginx. This install will use the Ingress Nginx repository and the Ingress Nginx chart within that repository. The installation is typically much quicker than the Cert Manager. All right, so the install was successful and we're provided with some getting started instructions. Let's now create some ingresses. We'll walk through the example ingresses quite quickly, just to give you a taste of how these resources can be configured. Let's start with the HTTP to HTTPS resource to highlight the use of that certificate the way we provisioned earlier. If I run a kubectl get certificate, we're going to see exactly that certificate and make sure that it's ready for use. We use the associated Kubernetes TLS certificate in our Ingress resource specification. In your specifications, make sure that you use the Nginx Ingress class if you want to use the Ingress controller that we previously installed. We have the SSL redirect here, and the TLS section tells the Ingress controller how to use the SSL certificate. In our case, we're going to serve on this domain and redirect the HTTP protocol to HTTPS. We have our routing defined in the rules section here, and some service and deployment resources back those routes. This particular Docker image is great for test setups as it echoes important HTTP request properties and the HTTP response. We can apply the specifications file and wait a couple minutes for the address property of the ingress to populate. This signifies readiness of the ingress. Note that this ingress controller is going to create all of our ingresses on a single IP. To access our workload on a domain name, we're going to take that IP and use it in a DNS A record. Let's do that in the console, and for my specific setup, I need to switch projects to get to the DNS zone. For our example ingress resources, we'll use subdomains of notomatic.io so we can set up an A record for all these domains with a wildcard DNS record. With that all set up, we can bring up our IDE again and start playing with the ingress resources. For the earlier protocol redirect example, let's test that out now in the browser. I'll explicitly set the protocol to HTTP so that we can see the request being redirected to HTTPS. The lock icon signifies that, indeed, we've redirected and are leveraging HTTPS. We also see the protocol captured in the response here along with other request details. Let's look at a couple other configurations to further get the wheels turning. For example, we can apply this cookies ingress and associated services and deployments. This is going to use the canary by cookie annotation to route traffic based on a cookie in the HTTP request. We're going to route to cookie unmatch if that cookie isn't configured, but cookie match if the cookie is set to always. This can be a tricky one to debug in the console, so there's a helpful command in the video description's GitHub repository to facilitate debugging. Let's use that approach and we'll see the different cases. We're first hitting the cookie unmatch, but can then set the cookie and be routed to an entirely different backend. The cookie routing is enabled by the use of two ingresses. Let's continue along here and look at a couple other examples. Perhaps we want to route based on headers. This adopts a structure which is very similar to that of cookie-based canary. However, we're expanding on the complexity a bit and matching based on regex. So if we go to headers.notomatic.io without the header, we're going to get header unmatch. However, if we supply a foo equals bar header, we're going to get header match. We can further clarify by doing foo equals ABC, which will give us header unmatch since it doesn't fall within the regex expression. We can also do things like route based on hosts. So in this configuration here, we see that a single ingress resource routes to one of two different backends based on the host. If I go to one.notomatic.io, we'll hit backend 1. If I go to 2.nomatic.io, we'll hit backend 2. Just a couple more examples to broaden the picture. We can use annotations for redirects. For example, here we're redirecting our before.notomatic.io to after.notomatic.io. In that redirect, it will preserve the request URI path. If we alternatively use this annotation, it wouldn't preserve the request URI path. The use of annotations for fine-grained ingress controllers is a common pattern across ingress controllers. In the browser, if we go to before.notomatic.io, it's going to redirect to after.notomatic.io. Further, if we go to a subdirectory, we'll see that reflected in our redirect. As a last example, we'll look at this regex ingress, which rewrites our URI path. For example, maybe we have a subfolder that we want to remove before the request hits our backend services. To accomplish that, our configured regex rewrite is going to match on the path here and then perform a rewrite. We can also see regex leveraged for routing. This first case is going to route based on regex path matching. We'll hit two different backends based on which regex expressions match the URI path. Okay, So let's do the regex rewrite, and we'll specifically navigate to subfolder/foo. As expected, when it actually hits the backend service, the path has been reduced to just /foo. Our examples are certainly not exhaustive. However, they may be helpful starting points, and you can copy them from the GitHub repo linked in the description of this video. In any case, we hope this demonstration has shown how Cert Manager and Nginx Ingress can be a really solid foundation for exposing your workloads in Kubernetes with high configurability, robustness, and security. In the demo, we set up this foundation with just a couple Helm and kubectl commands in our Cloud Shell IDE. We used Cert Manager for SSL certificates management and an Nginx Ingress controller for defining ingresses. Please check out the linked documentation, and we'll watch the comments section for any questions or concerns. We hope this video was helpful and want to thank you for watching.